The xenomorph life cycle from the Alien franchise has intrigued and horrified audiences for decades. Among its most iconic and scientifically fascinating stages is the facehugger, a parasitic creature designed to implant an embryo into a host organism. The science of facehuggers, while fictional, has enough detail and plausibility to warrant a breakdown from both biological and anatomical perspectives. Though imagined, the creature exhibits characteristics that parallel real-world parasitic species, offering insight into how such an organism might function if it were to exist. The facehugger is the second stage in the xenomorph's life cycle, hatched from an egg after detecting the presence of a host nearby. Upon emergence, it is already fully formed and instinctively seeks out a host for implantation. This implies a high level of prenatal development inside the egg, much like insects or amphibians that undergo complete metamorphosis. The egg must provide sufficient nutrients and environmental stability for the facehugger to develop completely. Its biological clock seems to be tied to the detection of movement or heat signatures, which could be achieved through a simple but highly sensitive organ analogous to pit organs found in snakes. Anatomically, the facehugger has a spider-like body structure with 8 finger-like legs that allow it to move quickly across surfaces and leap significant distances. The speed and precision with which it locates and attaches to the host suggest a nervous system capable of rapid signal processing and muscular control. The legs are equipped with pads or hooks, enabling it to grip the host securely. Their strength and dexterity rival, or even surpass, those of real-life arachnids or cephalopods. The central body of the facehugger appears to contain its main internal organs, tightly compacted but highly efficient in their layout. The most distinctive feature is the long, prehensile tail, which acts like a muscular whip and is primarily used to secure the facehugger's grip around the host's neck. This tail, in conjunction with the legs, helps to immobilize the host and create a stable connection during the implantation process. The tail may also serve as a sensory tool or aid in balance and direction during movement. In the act of subduing a host, the tail coils tightly, possibly exerting enough pressure to restrict the host's movements without causing fatal harm, ensuring the viability of the implantation. The reproductive method of the facehugger is particularly disturbing but biologically compelling. Upon securing a host, the creature extends a tube down the host's throat to deliver an embryo, effectively a parasitic zygote that will later mature into a chestburster. The tube must be long and flexible, similar to a proboscis in insects or an ovipositor in parasitic wasps. It functions both as a conduit for the embryo and a respiratory bypass, supplying oxygen to the unconscious host while the alien embryo develops. This dual-function mechanism suggests a high degree of specialization and evolutionary refinement. To maintain the host's life during this phase, the facehugger attaches tightly and induces a comatose state, possibly through a chemical cocktail of neurotoxins or anesthetics. This is akin to how certain parasites, such as the emerald cockroach wasp, manipulate host behavior and physiology for reproductive gain. The anesthetic properties would need to be incredibly effective, able to knock out organisms of varied physiology and body mass within seconds. The secretion may also inhibit pain receptors, suppress immune responses, and reduce inflammation to prevent the host from rejecting the foreign entity. From a metabolic standpoint, the facehugger operates with astonishing efficiency. It performs an extremely complex task, parasitic implantation, within a matter of hours and then dies shortly thereafter. This strongly implies a simultaneous reproductive strategy, similar to that of some species of salmon or mayflies, which live long enough to reproduce and then perish. The life of a facehugger is devoted to one task, reproduction. Its energy reserves, gathered during its embryonic phase, are used entirely during the implantation process. The absence of a digestive tract or feeding behavior supports this idea, suggesting it has no survival purpose beyond implantation. Its internal anatomy must be compact but highly specialized. It likely has a strong muscular system to support its movement and latching mechanisms. A simplified nervous system coordinates complex motor actions, and its reproductive system, consisting of the embryo storage and ovipositor-like extension, dominates its physiology. The oxygen-supplying mechanism for the host also indicates a specialized respiratory organ. While the facehugger does not appear to breathe in a conventional sense during attachment, it must carry or produce oxygen that it delivers to the host to prevent hypoxia. The ability of the facehugger to implant embryos in a wide range of hosts, including humans, animals, and even synthetics in some iterations, suggests incredible adaptability. This raises interesting questions about the genetic flexibility of the xenomorph species. The facehugger must be equipped with a universal set of tools that allow it to bypass various immune systems and host defenses. Its success indicates either a biochemical camouflage mechanism or a near-perfect anatomical compatibility with most vertebrate respiratory and circulatory systems. This implies evolutionary pressure to maintain genetic plasticity in the embryo while developing implantation tools that work across species. Another notable characteristic is the exoskeletal protection that shields the facehugger from physical harm. The tough, chitinous plating resembles the exoskeletons of arthropods, providing both durability and flexibility. The exoskeleton may also serve a thermoregulatory function, allowing the facehugger to survive in a wide range of environmental conditions. Considering the environments in which it has been shown to operate, from derelict spacecraft to planetary surfaces, the creature must be able to tolerate extremes of temperature, pressure, and radiation. The fact that facehuggers operate autonomously, without a central hive mind or direct control from a queen, underscores their evolutionary role as single-use reproductive units. They are pre-programmed with a behavioral script that triggers upon emergence from the egg and continues until the implantation is complete. This kind of instinctual behavior is similar to that of many insects, particularly parasitoid wasps, which perform incredibly complex tasks without learning or adaptation. The facehugger is essentially a biological robot, finely tuned to perform its function with surgical precision. After implantation, the facehugger dies, often falling off the host in a lifeless heap. The cause of death appears to be programmed obsolescence or total metabolic depletion. Having fulfilled its purpose, the organism has no further role. The process of death itself is clean and abrupt, avoiding decomposition that might otherwise alert predators or hosts to the presence of alien biological material. Its body structure may include enzymes that trigger self-destruction or rapid tissue degradation, ensuring that no trace of the parasite remains in the environment to give away the xenomorph's presence prematurely. This life strategy, while horrifying, is highly efficient. In the context of a hypothetical ecosystem, facehuggers could outcompete other parasitic organisms due to their speed, precision, and high success rate of implantation. Their main evolutionary disadvantage is their dependence on suitable hosts and the fact that they die after a single use. This creates a reproductive bottleneck that must be compensated for by high egg production from the queen alien. The entire reproductive strategy of the xenomorph species relies on quantity, with massive numbers of eggs and facehuggers ensuring that at least some embryos find suitable hosts. Facehuggers also offer a window into the idea of biological weaponry. If engineered, their design suggests a deep understanding of xenobiology, parasitism, and genetic compatibility. The creators of the xenomorph species, as hinted in the Prometheus and Alien, Covenant films, likely selected or evolved these traits deliberately. The facehugger represents a pinnacle of weaponized biology, efficient, single-purpose, and capable of hijacking other species for reproductive gain. This echoes ethical concerns in real-world biotechnology, where synthetic biology might one day create organisms with highly specific, potentially dangerous functions. The fusion of real-world biology with science fiction imagination in the design of the facehugger makes it a compelling object of speculative scientific analysis. It combines features of arachnids, cephalopods, insects, and even mammals to produce a unique organism whose reproductive strategy is terrifying yet elegant. Its anatomical precision, behavioral efficiency, and biological plausibility make it more than just a horror movie creature. It becomes a lens through which we can explore the boundaries of life, reproduction, and parasitism. The scientific realism of the facehugger lies not in its existence, but in its mimicry of known biological phenomena. Every aspect of its design has a parallel in nature, from its anesthetic saliva to its oxygen-delivering tube, and from its instinctual behavior to its simultaneous life strategy. The result is a creature that, though entirely fictional, feels biologically possible. This is what makes the facehugger so memorable and disturbing. It isn't just a monster, it's a plausible parasite that follows the ruthless logic of evolution. While we may never encounter facehuggers in reality, their scientific deconstruction offers value beyond entertainment. They prompt us to consider how life can evolve under extreme pressures, how parasitism can shape entire ecosystems, and how biology can be weaponized. In studying fictional organisms like the facehugger, we stretch the boundaries of biological imagination and prepare ourselves, in theory at least, for the strange and possibly dangerous forms that life may take beyond Earth.